Now, today's presentation. So I'm pleased to introduce Faisal Nanji of Tecumen. He is the Executive Director at Tecumen and a leading national expert in this field of data security, high tech, and of course, operating in the cloud. He's a contributing expert to High Tech Answers. He's done some posts for us, some guest posting, which was just terrific. And he has spoken at HIMSS, not only this past year, but the year before, and speaks, I think, at a number of conferences around the country. And we are so pleased to have him here giving an encore presentation of his presentation that he did at HIMSS to a pretty packed room. So, Faisal, I'm going to go ahead and make you the presenter, and I'm going to go ahead and go on mute, and we will be back around when we get to the Q&A portion, and I'll begin to moderate some questions. So, Faisal, you can go ahead and take it away.
Thank you, Carol. I hope everybody can hear me. If Carol decides that nobody can hear me, then she'll send me an urgent message by chat, and I'll understand that. But thank you very much for joining in today. Today we're talking about the cloud. Of course, everybody loves the cloud these days. It's really a wonderful new dimension in computing. And that's not the intent of this presentation. The intent of this presentation is to understand how to secure the cloud. So there are clearly some learning objectives that I went over at HIMSS. These are the same learning objectives clearly for today, where we want to describe the advantages of cloud computing. Second is identify the major concerns of securing health information in the cloud. Third is recognizing the key steps to overcoming health information security and privacy issues in the cloud. And then finally, let's consider how to define a suitable audit and compliance process to ensure security and privacy in the cloud. So those are our learning objectives real briefly. Well, everybody loves the cloud, and as I said, and what do we know about clouds? Well, they are amorphous, they are fuzzy, they are fluffy, and they move. The same goes for cloud computing. Like regular clouds, cloud computing is also an amorphous, fuzzy subject, or a fluffy subject, and it's a moving target. So that said, what I think you should really take away from this talk are four things. First is, what are the core technologies that are driving the cloud? So let's do a level set. Let's understand what are the core technologies that's driving the cloud today. Let's make sure we get our glossary and terminology right. Second is, what are the variants in cloud computing, and what attributes do these variants possess? Third is, as your organization increasingly moves to the cloud to deliver IT services, what are the key compliance and key security concerns we will encounter in the cloud? And finally, based on all of the above, how should we manage information security in the cloud? Well, three things have spawned the surge of interest in cloud computing. Excuse me. First is the ubiquity of fast networks for commercial use. Excuse me again. Second is a web-enabled ecosystem. These are standard protocols for information sharing that are on the web. These include TCP/IP, HTML, HTTP, and web services. And third and finally, it's the concept of the virtual machine. Of these, the virtual machine is the most misunderstood. So I'd like to go into a little bit more detail on what is a virtual machine and what it does. A virtual machine simply divides the resources of a computer into multiple execution environments to allow hardware and software partitioning, time sharing, partial or complete machine simulation, the emulation of an operating system, and finally, delivering quality of service. Yes, quality of service, this is important because if you have video or real-time voice traffic, you want to make sure that you have the correct bandwidth and you don't have fall-off or tail-off in your video traffic. So these are the five things that the virtual machine can do: hardware and software partitioning, time sharing, partial or complete machine simulation, the emulation of an operating system, and also delivering on quality of service. Virtualization is a lovely thing. However, it also makes security far more interesting, and the way it does so is in 4 ways. First, it increases complexity. Second, it strains infrastructure. Third, it can cause large-scale failure. And fourth, it requires special maintenance. I'd like to go into a little bit more detail about what these mean. Increasing complexity. Say you're a database administrator and you have several SQL servers all virtualized. Well, then you, as the database administrator, really need to depend on a separate set of administrators for your host servers that keep your virtual machines running. Any impact on your host will also have an impact on your SQL server. So how should you manage this complexity? So clearly, virtualization brings in more complexity. Second, virtualization also strains infrastructure. A full-blown virtual machine environment will need additional infrastructure. A storage area network, for example, is mandatory, as is dedicated management software and a dedicated high-speed IP network. So clearly, virtualization can strain infrastructure. Third, virtualization can cause large-scale failure. If you virtualize your environment, for example, but have not specifically designed for service availability, then a host running multiple virtual machines is really a single point of failure. So if a host goes down unexpectedly, for instance, because the CPU is overheating and shuts down, it takes down all the virtual machines with it and all the applications running under that virtual machine. So it can cause large-scale failure if you haven't really thought about designing for large-scale implementations. And then fourth, virtualization requires special maintenance. Many virtual machines, for example, will be offline at some point in time. So if you want to patch a virtual machine, or if you want to do some kind of maintenance of a virtual machine that is offline, you have to make sure that you are considering the offline virtual machines as well as the online virtual machines. So you have to have a very good understanding of what's offline in terms of your virtual machine environment and what's online. So virtualization does bring to these several concerns. That said, we find that this combination of fast networks, the web ecosystem, and virtualization offer us 4 things that really are the basis for cloud computing. These 4 things are computing capability on demand, resource pooling, such as storage and CPU resources. Third is rapid deployment and scaling of IT services. And fourth, it allows us to easily measure what's been used in terms of IT services. So let me kind of go into a little bit more detail on each of these things. On-demand self-service is where a consumer or a user can unilaterally provision computing capabilities such as server time and network storage as needed automatically without requiring human interaction with a service provider. This notion of without requiring human interaction is an important one. Second, resource pooling. What is resource pooling? Resource pooling is where the provider's computing resources are pooled to serve multiple consumers using a multi-tenant model. So different physical and virtual resources are dynamically assigned and reassigned according to consumer demand, but in a multi-tenant environment. So in essence, you as a user of the cloud are actually sharing a lot of the same physical infrastructure that is being offered through your cloud provider. The third thing that is a wonderful attribute of the cloud is that it allows for rapid elasticity. That is, capabilities can be rapidly and elastically provisioned. So to a healthcare provider, the capabilities available for provisioning often appear to be unlimited and can be purchased in any quantity at any time. This rapid elasticity is a really wonderful feature, and it means that you don't really have to worry about buying lumpy sets of assets that are so typical when you're developing IT infrastructures. And then finally, it allows easy measurement of what's being used. So resource usage can be monitored, controlled, and reported. And this provides transparency to both the provider and you, the consumer or end user of the service. So these are the key wonderful attributes of cloud computing, and they really do set the stage for some really impressive things in the years to come. Well, unfortunately, the plot thickens, because using these attributes of the cloud, we can make different types of clouds. We can make fat ones, skinny ones, woolly ones, ones with faces on them. Kidding aside, really, in short, there are three principal service models. First is infrastructure as a service. Second is platform as a service. The third is software as a service. These differences among these different variants are critically important because they carry important ramifications on what your security and compliance requirements and responsibilities will be. So again, the variants suggest some interesting requirements for security. Each of these variants have a significant and important ramification on what your security and compliance requirements will be. So let's go to the first one, which is infrastructure as a service. Infrastructure as a service includes the infrastructure stack from the data center facilities to the hardware platforms that reside in them, and then the logical connectivity to these resources. So IaaS or IaaS provides few, if any, application-like features, but it allows for enormous extensibility. So for us users, especially in healthcare, this really means less integrated security capabilities, again, less integrated security capabilities and functionality beyond protecting the infrastructure itself. But it also means significant extensibility. So in short, this model requires that operating systems, applications, and content must be managed and secured by you, the healthcare provider. So that is basically infrastructure as a service. If we go a little step further and build on top of infrastructure as a service, we get to platform as a service. And platform as a service, or PaaS, sits atop IaaS and adds an additional layer of integration by providing an application development framework, such as whatever your development environment is, such as Java or C++ or C#, as well as some middleware capabilities. These added functions in middleware, for example, can include database and message queuing functions, which are so central to larger infrastructure environments. Now, PaaS is primarily used to enable developers to build their own applications on top of the platform. That is, a lot of times developers will come in and go to their CIO and say, hey, I know we don't have any budget this year, but if we could just start practicing our application in a PaaS environment, we can really make a lot of headway. So what happens a lot of times is developers will come in and present an argument to a CIO or to the head of IT or infrastructure and say, listen, we've got an interesting new point that we want to test. Can we just develop our pilot application on a PaaS environment? And you might say, yes, then. But because of this capability, you have to be very careful to make sure that this is done very, very carefully in terms of your security posture. So if your development team is thinking of moving part of its development environment to the cloud, please make sure you grill them on the security issues. This has been found to be a concern in many areas, where rogue developers have gone on and developed platform as a service solutions, and they have found that this actually has an impact on the security of the overall infrastructure of an environment. The final cloud variant is SaaS, or software as a service. Software as a service, in turn, is built upon the underlying IaaS and PaaS stacks. And what it really does, it provides a self-contained operating environment used to deliver the entire user experience, including the content, its presentation, the application, and management capabilities. The most successful example of this is, of course, Salesforce.com, which I don't know how many health providers use, but I'm sure maybe a couple do so. Now, SaaS generally provides the most integrated functionality built directly into the offering, but it has the least consumer extensibility. And because of this, a SaaS provider must guarantee a relatively high level of integrated security. That is, the cloud provider bears a responsibility for most of your information security, apart from, let's say, endpoint control and managing your internal firewalls, which is still going to be the responsibility of you, the healthcare provider. The key takeaway for security architecture across all these three different variants is that the lower down the stack you go, the more security capabilities that you, as the cloud consumer, are responsible for implementation and for management. Again, I think this word bears repeating, that the more security capabilities you, as the cloud consumer, are responsible for implementing and managing, the lower down the stack you go. Now, in addition to SaaS, PaaS, and IaaS, you may also see mention in the press of certain cloud deployment models. And these are known as public clouds, private clouds, hybrid clouds, and community clouds. And I don't know why they've really done this over the last couple of years, but I think it's mostly been done by vendors to add confusion more than anything else. So let's just get rid of the confusion now. A private cloud or internal cloud is really for provision of all your IT services. So your CIO owns all the resources in the cloud. All he's done is he's manipulated or managed the offering of his IT services to mirror that of what the cloud provides. So this is the private cloud. It's not that much different from what you might already have, but that's what it's termed as. All your IT services are now provisioned using attributes of the cloud. The public cloud, which is the second type of cloud, is when you don't have resources to build your own environment, so you use a provider such as Amazon. And this is typically a very small shop or someone with a unique business need, or, as I mentioned before, some developers who really want to test out something that's interesting to them. The third type of cloud, and probably the most common cloud, is going to be the hybrid cloud. This is a mixture of your organization's own resources and infrastructure, as well as an outside organization providing you some elements of the infrastructure. This is going to be the most typical because you are, as a health provider or an entity, not typically just going to throw out all your infrastructure into the garbage. You're going to actually retain a lot of it and then work with a cloud provider to make your operations hum. So the hybrid cloud is exactly that. It's a form of a hybrid. And then finally, there is this notion of a community cloud, which is an interesting new service model or variant. And the best way I can describe this is to give you an example of what a group of hospitals in Toronto are doing. And this is in Toronto, Canada. So this group of hospitals in Toronto are now sharing a pictorial archiving system, or a PACS system, which, as you know, is confoundingly complex and very expensive to maintain. So in this particular case, one hospital manages all the infrastructure, but the images such as X-rays and CAT scans and so forth can be shared readily across multiple hospitals. The managing hospital charges an administrative fee for providing all these radiology groups with their images, but everybody now has access to these images. I mean, if we think about how non-interoperable all our pictorial archival systems are today, this clearly sets an example where imaging systems can become really vastly vendor neutral, and we know that can actually reduce costs for us in healthcare. This has been, again, as I mentioned, done successfully in Toronto, and I think it's clearly a harbinger of things to come in the near term. There are lots of, obviously, possible uses and users in healthcare. We've talked about innovative imaging pictorial archiving systems. But I think one big area also is going to be electronic medical record delivery and health information exchange. There are going to be some really significant ways in which we will be allowed to use electronic medical record storage, delivery, and dissemination using the cloud. And there are a couple of vendors out there who really do this quite well. I really don't want to taint the subject with suggesting a particular vendor, but if you do a little bit of homework, you will find that there are a couple of vendors out there who already provide excellent EMR solutions through the cloud. We can also consider that with the fact of the patient, with the new Healthcare Reform Act, as well as the HITECH Act, that there will be many, many more uses for data mining. And it just so turns out that data mining is a very, very heavy processing, heavy overload, and a database component. So increasingly we will find that data mining, such as for accountable care organizations, will be a very interesting and good use for the cloud. That's all very good. We clearly can see how the cloud will help healthcare by just viewing a few of these examples. And it clearly can be cheaper and faster. But is the cloud more secure? Well, unfortunately, cloud computing isn't necessarily more or less secure than your current environment. And I hope I haven't burst anybody's bubble today, but it isn't necessarily more or less secure than your current environment. In some cases, moving to the cloud provides us an opportunity to re-architect older applications and infrastructure so that we can meet or exceed modern security requirements. At other times, the risk of moving very sensitive data and applications to an emerging infrastructure might just simply exceed your tolerance as a healthcare provider. So it's a double-edged sword. However, in my view, cloud security does have vast potential to surpass the levels of information security that are possible today, but only if it is done right. And the reason why I believe so is because it provides us with a completely new way of thinking about how to deliver IT. So rather than doing things in a Rube Goldberg fashion, as we've done in the past 20, 30 years with the Internet, we can think about delivering security in a much more organized, systematic way. So cloud security does have that potential, but it's up to us to seize this advantage. So how is cloud security different? Well, let's consider a traditional or non-cloud data center security requirements and approach. Again, this is something that's not in the cloud mode, and there are several things that occur in a physical data center. First is physical configuration management governs the deployment and controls implementation of your infrastructure. That is, once you configure a physical system, you rely on a specific set of controls. The cloud lets you escape from this throttle, so you can be very fine-grained about your controls. Second is this notion of physical control. So, for example, if you are facing a massive, rapidly spreading virus attack, you can literally pull the plug in a physical data center and shut down the system. Well, with the cloud, it's not so easy to pull the plug because you don't know where your data is, you don't know where your applications are. So this notion of physical control also is important, and it has security ramifications. The third thing is, in regular data centers, you typically have one set of enterprise policies and procedures for separation of duties and control. But within the cloud, the service providers or the cloud providers have to deal with multiple enterprises. Now, your cloud policies maybe need to be very well tailored. So when you use the cloud in whichever variant you have, IaaS or PaaS or SaaS, you typically get a generic set of controls and policies and procedures from your provider. Then what you have to do is you have to see if this meets your organization's own internal standards. For folks like us, obviously you know that this can be very dangerous. For example, we might have very strict encryption standards that might be violated by the service provider. So in the cloud, things do change. In the regular data center, we do know they're fairly fixed. And then fourth, patch testing and patch management is done one physical platform at a time in the cloud. In a physical data center. In the cloud, however, one command can update all your virtual machines. So this really does make a difference. And then finally, in the physical data center, the data and your applications are where the machine is and where your networks are. In the cloud, you have no idea where your data is. You may have no idea where your applications are. So these are particular concerns that you have. And just to amplify that, there are several other things that we need to really focus on as this physical visibility is lost. So with the cloud, unlike in the traditional center, for example, our concerns are where is the data and where is the processing being performed. So in Europe, for example, they have very, very strict privacy laws, and that place great restrictions on where the data must be processed, stored, and controlled, three separate things. And likewise, here in the U.S., I know we have a patchwork of state health care and privacy laws. And because we operate across states, we might have to yield to the lowest common denominator or the highest common denominator, depending on what we want. So where our data is being processed and where the processing is being performed and stored is extremely important. And we need to have a very good understanding of this when we are working with the cloud. And so we have to ask our vendors this very carefully. Where is the data? Second is, who else can see your data? More accurately, who might be able to see your data? Remember, now our data in the cloud is not housed in a single secure physical data center anymore. So who can see the data might be several people that you may not want to see the data. So then you might ask, well, who has actually seen the data? And how do you know who has seen this? And so this is where the cloud provider must come up with the right audit tools to demonstrate to you and to confirm to you that person X or person Y has or has not seen the data. Think of how many different types of administrators we might have. All of whom might have access to the data. There will be a storage area network administrator. There will be a virtual machine or host administrator. There will be a database administrator. There will be an application administrator. There will be a network administrator. All of these administrators may have access to our data, and we want to make sure that as a health provider that we're very, very careful about who has actually seen our data, because if we allow people to see our data without permission, we have suffered from a breach, and we don't want to be suffering any breaches. Fourth, we also need to know whether data has been tampered with in the cloud. So do we have the right tools and processes to understand if data has been tampered with in the cloud? That is data integrity checking. How is this done? How do we know that if we send a byte with a 1 and a 0, it doesn't translate into a 10 and a 20 on the other side? What is the data integrity in the cloud? How do we develop this? Do we have the right tools for this, understanding the data integrity within the cloud? And then fifth is, how is processing configured? Who will manage this processing for you? Do you trust these people? Is your provider really managing your cloud processing as well as they claim? And how do you know if this translates into good security for your specific cloud? Again, a lot of the vendors will tell you lovely stories, but how do you know if this really translates into good security for your specific cloud? So we have to be very careful in making sure and sifting through vendor claims from what is really reality. And then finally, does backup happen? how and where, and how does the cloud provider prove this to us? So as physical visibility is lost, we gain all these issues in the cloud. If we handle these correctly, we can do fairly well in the cloud, but these are some really interesting issues. Now, I just want to go on a small but critical topic expansion, because for those of us in healthcare, and especially in compliance, we know, as all of us in IT are, that we are drowning in healthcare compliance requirements. This is not necessarily a bad thing, because we are, after all, dealing with saving lives and improving healthcare. So we have a number of compliance requirements, including medical fraud attestations, e-prescribing attestations, mental and behavioral health attestations, HIPAA security, policy and procedure management, and so on and so forth. There are a lot of compliance requirements in healthcare. Our IT teams, in my view, should have the forethought to serve multiple compliance requirements in healthcare. And the cloud is a wonderful way for us to really rethink how we provide this heavy information dissemination burden. So as IT professionals then, the cloud is not simply about security, but our ability to be strategic about how to leverage and extend the cloud to other areas of compliance. Now just think about how many IT professionals have to constantly worry about audits. We have systems reviews, we have transaction reviews, we have policy and procedure reviews, and risk assessments. And in the cloud, these will be even more frequent, because nobody really knows what the cloud is. If you ask anybody in HHS, they will tell you that we really don't fully know what the cloud is. So the best thing to do is to audit you more. So we will get a lot of more audits, and these will be performed by the Department of Health and Human Services, or the CMS, independent review organizations such as the Joint Commission. The states will get involved, the Federal Trade Commission will get involved, the payment card industry will get involved, and so on and so forth. Again, this is a very, very heavy information dissemination, storage, and analysis burden on us IT folks. Well, it just so happens that information security is tied very closely to information movement. And information security will be among the first compliance items we design in for the cloud. So if we do this correctly for information security efforts, we can substantially help other compliance needs in healthcare. So this is really a call to arms, a call to action for us to really think about using information security as a model or a template for really helping compliance overall in the cloud. So at the end of the day, what we really require is an interconnected strategy between compliance, information architecture, and information security. This is the one thing that I would hope that you would absolutely take away. I know for all of us who are IT professionals, we really sometimes scratch our heads at wondering why the compliance folks don't really get it. Well, the compliance folks, unfortunately, don't understand technology. It can be fairly complicated. They don't understand it's very difficult to produce a report on the fly for a certain specific requirement. So with the cloud, we can really deliver on this in a much better way. Now, why do I say this? Well, first and foremost, the cloud presents those of us in IT and security a really once-in-a-career opportunity to make information security better, faster, cheaper, more efficient, and less intrusive. Because, and this is why, because cloud platforms are still developing, we have unprecedented opportunities to embed information security and technologies deeper into our infrastructure. So, for example, security protocols can be built into the virtualization layer. This creates stronger, simpler, and more unified information security systems. In particular, as virtual machines move across the cloud to perform their functions, they can take their policies and protection with them. So the virtual machine now has the embedded policies and procedures for security embedded within it. And this is a critical and a fundamental departure from the current way of thinking. But clearly, before you run to your nearest cloud store to build your internal cloud, let's have a reality check. Your organization may or may not be ready for the internal cloud. So to be ready, to be cloud ready, you must really have several things. First is, have you standardized your most commonly repeated operating procedures? That is your configuration management, capacity management, your patching, your image creation, and your lifecycle management of the virtual machines in your environment. Are these already highly repeatable processes? If they're not, you may not be ready for the cloud. Second, can you provide self-service access for users? And what do I mean by this? Well, a good cloud services portal should follow a consistent workflow that ensures that the requester, that is the user of the service, has the right and approval to deploy that resource. It also means that there is a set of consistent steps in selecting the resources to deploy it. So every user who wants to obtain more information, more service using the cloud has the same kind of set of steps that he goes through. And then finally, this workflow should also include approval from management and or the architect, the enterprise architect, before any automated deployment kicks in. So this notion of self-service access is important and very, very useful, but only if it's done in a very consistent workflow-like way with certain parameters already installed. And then finally, you have to ask yourself if you're cloud ready by trying to understand if your business units are ready to share the same infrastructure. Many business units, as we know in healthcare, do not really want to share infrastructure. We know, for example, some cardiologists may not get along with the radiologists, and they don't want to have their systems running on the same servers, even though it really doesn't matter to them, but it's just the way that they are. So for a cloud solution to make economic sense, it has to have periods of high utilization. Otherwise, the resources will sit idle for long periods of time, which really destroys your return on the investment. So we have to make sure that our business units are ready to share the same infrastructure. This doesn't mean we give them poor service. It just means, are we ready to share? Some people aren't ready to share stuff. And if your environment is not one in which people have a ready habit to share information, that's a problem. So you have to be very thoughtful and understanding of if your business units are ready to share the same infrastructure. The major cloud compliance issues then become threefold, really. The cloud forces user organizations to really fully examine our methods for data ownership and control. That is, we may have to revise our models for establishing trust and consequences and the chain of custody of the information that we provide. We also have to really think about how we might be changing access and authentication. So, for example, providers of cloud services must give user administrators the access and the privileges needed to do their jobs. That is, user organizations should clearly retain control over IT policies and assets, even if they don't own or directly operate those assets. So this notion is an extremely important one. The service provider will tell you a lot of times that, well, you know, we really don't know how to give your user administrators access to inside information that exists on our hosted service. But you should demand that. And it's important because you must, as a user, still have control over your IT policies and your assets. One other important point on this notion of access and authentication is that interactions between software and systems will often equal or exceed those between people and machines. The cloud only accelerates this trend. So consequently, it's imperative for IT and security processes to account for the reality that a user in the cloud may more likely to be a machine than a person, or it may be a machine acting on behalf of a person. This, incidentally, has very, very profound implications on how identities are provisioned, authenticated, and managed in the cloud. And this is one of the big areas of research and development in the cloud. And you might hear terms in the future about things such as federated identity management in the cloud as something that's emerging and that's something that's coming to the fore. But it is an important consideration that machines may be representing us, and that this has now significant implications for access and authentication. In my view is that the best way to ensure security for the cloud is for enterprise customers is to require maximum transparency into your cloud provider's operations. You will be sharing resources with potentially lots of business units, external or internal. And so you really need to know what is going on. This transparency, this ability to understand what's being audited, who's auditing it, and getting audit reports and understanding the policies is very important. So this notion of transparency is particularly important. This kind of leads us to key cloud security concerns, and this is a little bit more granular, but it's important. With virtualization software, we can suffer from what is known as hypervisor risk exposure. What is a hypervisor? A hypervisor is simply a management console that allows you insights into what's happening on your virtual machines and a server that hosts perhaps several virtual machines. And it just so turns out that there might be multiple people who might have access to this hypervisor. So if you have excess hypervisor exposure, it can be very risky for you. So we have to be very concerned, and we must ask the provider who has hypervisor access and why, and what are they doing about it to monitor it. The second thing is in the cloud, we have this inability to determine the location of data or processing. So let's make sure that in our vendor contracts, we really get a very good understanding of where our data is located, where it's being processed. Again, as I mentioned, this has significant implications, especially in the European Union, but I would think that over time, because of our patchwork nature of state health regulations, this might also have an impact upon us. Massachusetts, for example, has very, very stringent privacy requirements, and North Dakota probably less so. So we have to be very concerned about this, where this data is being processed and under what regulations are they being processed under. The third thing that's of concern to me in the cloud is that mobility among virtual machines, really it contradicts traditional control principles. And as you know, traditional control principles have been brought about by those fairly boring accountants that we all love and hate so much. But they have done a good job over the years. But with this mobility among virtual machines, the boundaries become unreliable and blurred. The mobility can occur because you can simply transfer one virtual machine from one physical server to another, which might be, for example, in Belarus versus in China. Who knows? The point is that this mobility makes boundaries become really unreliable and blurred. So we have to be very, very careful about this notion of mobility. And then finally, in the cloud, we really have very limited visibility into the host operating systems and the virtual network because the cloud provider is doing that for us. It was then, therefore, difficult to find vulnerabilities and assess and report on vulnerabilities and on configuring and patching new systems because we really don't have access into this visibility. We are going to be relying on the cloud. So again, I think what this means is that we have to be very careful as we design our contracts and as we write our contracts that we undertake and understand the full notion of what's going on in the cloud and that we have compensated for these. This leads us to some very, very granular issues. Again, of most import is that many, many traditional security tools, which are optimized, unfortunately, which are optimized for physical data centers, don't do a lot of what needs to get done today. So these tools that we currently use, which are optimized for physical data centers today, don't really do a lot of what needs to get done. For example, our security policies will need to shift up the stack meaning IaaS, PaaS, or SaaS, to match the logical attributes that we want of them. And they will need to shift up the stack because, as we talked earlier, a software as a service provider will be providing a much more better security than, let's say, just an infrastructure as a service provider. So our security policies will need to shift up the stack, and therefore we may need to have multiple types of security policies and procedures. And as you know, this can get to be difficult, but I just want you to be prepared that you may need to rewrite some of your security policies and procedures so that it can shift up the stack to match the logical attributes of what the particular cloud provider is offering you. Second is a concern or a granular issue is network access and control and intrusion prevention. Because virtual machines can be quickly introduced into the data center with little oversight, security exposures can be introduced as quickly. Now, traditional discovery tools and processes are generally quite ineffective, I found. So your intrusion protection technology must automatically now protect virtual machines as they come online or as they move across the data center to a different server or to a different location. So we must be able to protect our virtual machines on the fly. And right now, there is a dearth of tools that allow us to do that. But I think this is getting remedied fairly quickly. So there is still clearly hope for us here, and this will get done. The third thing that's important is this notion of rootkit detection. We must be able to transparently inspect virtual machines to detect the installation of rootkits. Well, what are rootkits? Rootkits can be worms, trojans, basically anything to sniff inside your virtual machines. And since one virtual machine sitting on the same server, if it can sniff somebody else's virtual machine, then you don't know whose virtual machine it is and who's trying to sniff at your data. And that's a problem. So we've got to identify rootkits. We've got to understand what these rootkits are, and we need to have better tools for sniffing out rootkits in virtual machines. The final thing is that with virtual machines is that there is a lot of inter-virtual machine traffic going on. And so we need to be able to analyze this. And this is a blind spot, I think, of special concern between virtual machines of varying trust levels. One thing, for example, you want to make sure is that network traffic between virtual machines within the same physical server does not exit the machine. Because if it does, you may ask yourself, well, why is it exiting the machine? It could only be a bad person, for the most part, trying to send off data that belongs to that virtual machine and that server outside of its purview. Now, traditional host and network intrusion prevention systems do not have this kind of visibility into traffic between virtual machines. So this is an area where I think the security vendors will need to do a better job. And from what I understand and from what I see, they are trying to do this. But it's still not as mature as we would hope it to be. So the key considerations that I have for you is that fundamentally a shift in mindset will be required for the cloud. First, we will have to move away from physical attributes for meeting compliance. And we must be flexible with our policies, procedures, and controls in the cloud. This flexibility is going to be extremely important for us. And we must know how to prepare and use and become flexible. Second is we must know what is the context of our own cloud or clouds. This includes understanding our application, the various identities of the folks who might be accessing the information in our cloud, and the content that we have in our cloud. These two major areas underpin or should underpin our approach to support secure cloud computing. So the core recommendations that I have is that you really should change your mindset about information security in the cloud. I think what we really have to do is think of delivering security as a set of adaptive services that are delivered via programmable infrastructure to create adaptive zones of trust. I want to repeat this just for a second because I think this is really important. We have to think of delivering security as a set of adaptive services that are delivered via programmable infrastructure to create adaptive zones of trust. Second, we must get our security vendors to deliver security controls in a virtualized form. They must be made more context-aware. They must be made clearly work better with our legacy static security infrastructure, and we must have better security controls overall in a virtualized form. Third, we must be able to express security policy across both physical, virtualized, and private cloud computing environments. This is an important consideration. It's a core recommendation that I think we need to consider. And then finally, and this is my biggest bugaboo, I think, in all of compliance and healthcare, is that we don't really separate security policy enforcement from IT operations. Typically, we find that the Chief Information Security Officer reports to the CIO. It's not necessarily the worst of things, but it's like the fox running the hen house. The fox may be well-meaning, but he is still a fox. So we must maintain the separation of duties between security policy enforcement and IT operations. And if we do all those things, we can go from a weeping cloud to a smiling cloud to being on cloud 9. And thank you very much, and I'll be happy to take your questions.
Well, thanks, Faisal. I appreciate that. Do you want to move to your contact slide so people can use contact slide, right? Yeah, just in case people want to get hold of you afterwards. There you go. Yeah. So you can go ahead and chat a question to me. I've got a few of them that have come in, and we've got a few minutes here. So why don't we just go ahead and take a couple questions. The first is that you mentioned earlier that the cloud, of course, is not right for every organization. And I think you mentioned 4 different areas to look at. What would be the first thing an organization would do?
Well, you really have to see if you really are right for virtualization. So are your operating procedures, you probably are already on your way to virtualization at some level. But you want to make sure that whatever virtualization you're doing is really automated as well as possible. So your image creation, your configuration management, your lifecycle management, your image management, all of that, if that's automated as well as possible, then I think you're well on your way to really using the cloud. If you don't do that, then I think you might fall flat. And it's a problem, but you have to be careful about how automated you are already. Sorry.
Sort of a segue along the same lines. When you talk about with the cloud that your organization should have high utilization and sharing,
yes.
Actually, a couple of people chatted that question to me. Like, how do you? I mean, I guess that's not an intuitive answer to that. I mean, are there benchmarks, or what should you be looking at when you talk about this issue of high utilization?
Yeah, I would think that, from what I've looked at in the past, I think there's a general term that if you will have 10 to 20, 30% server utilization for all your servers, then it's clearly low. Typically with virtual environments, if you're able to get to 70 or 60, 70%, 80% utilization for a particular server, so that will host several virtual machines and several applications, that's a pretty good sign. But I think there are many measures to look at that, as you said, and I don't have a specific answer, but I think in that range is about right.
Okay. We have organizations, of course, of varying sizes, right?
Yes, absolutely.
Yeah. From a security standpoint, is it okay to use cloud for backup storage?
Yes, I think it can be. The issue is you have to worry about where the data is going to reside, what the restoration capabilities are, who has access to that, and if it's actually going to be very quick to restore your backup facilities. For example, I use right now personally I use something called Carbonite for my personal.
Sure. Yeah.
And you know that's really works well for me personally. But if you're talking about a hospital with real-time EMR records and so forth, you know Carbonite's not the way to go, and neither is something like an Amazon perhaps. But I would think that you would really have to drill the vendor on this, and there are clearly some good vendors out there who have really thought about providing this service that allows for very easy restoration, very quick restoration, very tight access, and you can bring this up. There are, for example, lots of hosted solution providers that do a fairly decent job of this as well.
Okay. I'm going to take one more question, and for those of you who may have additional questions, you can email Faisal offline at his email address here, and I will also send out a copy of the recording to all attendees as well. So one last question is, with regards to actual policies and procedures, which you actually talked quite a bit about, how do you keep up to date with this? I mean, it's cloud, it's moving fast.
Yeah, you know, I mean, I think what you do is you take this lens of confidentiality, integrity, and availability, which is really the fundamental cornerstone of information security. What you're really trying to do with information security is do those three things. You want to keep your information confidential. You want to make sure that this information maintains its integrity, whether it's being stored or whether it's being transmitted. And you also want to make sure that this information is available. So as you look at your infrastructure, you have to perhaps think about tailoring these specifically. So there will be compensating controls there, and yet if you do all those three things correctly, and you engage in what we call defense in depth, then you start off with this philosophy. You will be on your way to, you will be on the right track. There is no one single answer for how to do security right. All we have to really worry about is those three things: confidentiality, integrity, and availability. And this should always be reflected in our policies and the way we execute in our IT environment. So I think that's really important.